Good evening, ladies and gentlemen, and you're very welcome to this evening's lecture on grid connections for small-scale renewable generation. My name is Ronan Keane. I'm the chair of Engineers Ireland Cork region. And tonight's lecturer or speaker is Rory Mullan of MullanGrid. So Rory is a senior consultant director of MullanGrid. He's a qualified electrical engineer and has worked in the Irish electrical industry for over 20 years in various commercial and technical roles in utility and consultancy sectors. Rory is also a member of the Irish Wind Energy Association, Renewables Northern Ireland and Irish Solar Energy Association grid committees. So without further ado, I'll hand you over to Rory.
Thanks a lot, Ronan, and thanks to Engineers Ireland for inviting me to come along this evening and give you a bit of an overview of grid connections for small-scale renewable generation. I think Ronan's given me a good introduction there. My background, I did electrical engineering up in Queen's University. I worked in NIE, ESP and EirGrid, and for the past 13 years, I've been a grid connection consultant based in Dublin, and I work across the island helping renewable generators in Northern Ireland and the Republic to connect. And that's very much our job, working right the way from feasibility stages through construction, and we're actually doing more and more work on the operational end as well of monitoring how wind farms are operated on the system. For a long time, I suppose onshore wind was our bread and butter work, but more recently we've been, doing work in areas like solar. So, for example, in Northern Ireland, some of the first solar farms were connected. In the picture there is an example. It's probably the largest solar farm in Ireland at the moment. It's 30 megawatts AC, about 44 megawatts DC. And I was involved in connecting 5 or 6 solar farms in Northern Ireland, which is fairly topical because over the next year, 2 years, we're going to start connecting solar farms in the Republic of Ireland. We've obviously got some rooftop solar already, but we've never actually done sort of large-scale deployment of solar yet in the Republic. As well as sort of the day job of being a consultant for renewable developers, I'm also involved in the development of some of the policy, mainly through the renewable associations. So I've been on the grid committees of the Wind Association, the Solar Association, the Northern Ireland Renewable Industry Group for the past 13, 14 years. And I'm also involved in other sort of roles within the likes of IWEA. So today I've been asked to come along and talk about grid connections for small scale generation. And in terms of small scale, mainly focused sort of from 11 kilowatt to up to 5 megawatts. And I'll talk a wee bit about Microgeneration, which is sort of below 11 kilowatts, and talk a bit more about larger scale generation. But I'll try to focus mainly on, trying to explain the rules and processes for what's generally referred to as small scale generation. Just to put, I suppose, the whole thing in a bit of context before I get on to maybe the nitty gritty of connection processes, like where are we in terms of connecting renewables in the Republic? Well, at the moment our figures would have us at about 38% renewables, based on, a normal year's demand and a normal year's wind. The 2020 has been far from normal in both those regards. It's been an extremely windy year and we've had a big drop in demand because of COVID. So the combination of both of those probably means that we're probably quite close to meeting the target this year. So the government had set a target back in about 2008 to achieve 40% in 2020. So we've got very close to it. But at the same time, there's a lot of renewable projects in development, so we will exceed that 40%. A lot of it is made up of onshore wind, but there is contributions obviously from the historical hydro that will be on the system and some biomass as well. In terms of the actual demand, so it's 40% of our total demand. So our total electricity requirement in Ireland at the moment is about 31 terawatt hours of electricity. And we're supplying about, 38% about that. So about 12 terawatt hours at the moment. I suppose the interesting thing sort of looking forward, and that's a good achievement so far. Considering back in 2010, we were only probably somewhere around 10 or 12%. So we've had, a big growth over the past number of years. But there's big ambitions ahead of us. And what's interesting now is we're not just setting a target for 2030, The government in the Climate Action Plan last year set a target of 70%. We're actually also now, setting out a longer term vision that, we really want to fully decarbonize our electricity system. The talk is now about how do we get to not even 100% renewable electricity, but how do we get to 100% renewables? I think the first step to achieve that is to get to 100% renewable electricity, because a lot of the renewable energy is going to come from, the electricity sector. So it's quite an exciting time to be involved in the industry. And if you actually look at what the challenge is in front of us, so the first thing is we're on about going to 70%. And it's not about moving the dial from 40 to 70. It's also the fact that pie is going to get a lot larger because of demand growth. So we have quite a lot of demand growth projected in Ireland, combination of, a lot of data centers, particularly in the Dublin area, hopefully more into the regions going forward, but also electrification of heat and transport. So as well as going from 40 to 70%, we're actually, it's 70% of a larger sum. So the demand projections, from the likes of EirGrid for 2030 is about 41 terawatt hours. Now, we have to see where that goes. A lot of it depends on the growth of the data center sector, but you only have to live up around Dublin and see the amount of, data centers being built and infrastructure going in to know that that's definitely heading that direction. But maybe what happens in the second half of the decade in terms of data center growth is still fairly uncertain. But we now have to do 70% of 41 terawatt hours. So that's about 29 terawatt hours. So we have to go from 12.5 to 29. So that's actually more than doubling the amount of renewables in our system in the next 10 years. So that's a big challenge. And you can see that it won't just be from, so this is one of the scenarios that EirGrid have put forward as to how to do that. They have a number of scenarios. Their Tomorrow Energy scenario workstream. It's an excellent piece of work. In this scenario, they were looking at, almost doubling the amount of onshore wind. We start seeing solar, on the system, 2,000 megawatts. Personal opinion, I think we'll do a lot more than 2,000 megawatts, both rooftop solar and ground-mounted solar. And we start seeing the emergence of offshore. So at the moment, we've only one small offshore wind farm, but there's definitely a huge, like in the last 2 years, I've seen that the whole offshore sector in Ireland has really taken off. There's a lot of resources going into it. And to achieve the 70% in 2030, I think it's undoubtable we will need offshore to achieve that. Now, exactly how much still to be determined, depending on contributions from the likes of onshore wind. But I think that's sort of one aspect of the big challenge of what's ahead of us. The other aspect is, well, how do we actually have a power system that can accommodate 70 or 100%? So a huge amount of work has been done in the past 10 years to design our system to do 40%. So now we need to start on that journey of designing it for 70%. But also with probably a view on the fact that we're now looking at 100%. And I think what's different sitting here now compared to, say, 10 years ago. 10 years ago, we were looking at 2020, 40%. There's no real vision beyond that. Now we're sitting here in 2020, looking at 2030, but seeing a vision beyond that. And that's why I think we do need to look at the power system even beyond 70%. To get to the 40%, we needed things like the East-West interconnector that was built connecting Meath to Wales. We've seen EirGrid's DS3 program that's, it's increased the amount of renewables we can have instantaneously on our system, bringing in new services, bringing in a lot of new tools in our control rooms to be able to control that amount of renewables on our system. And we've also seen the start of batteries coming onto our system. There's a reasonable number of utility scale battery projects in development across the island at the moment. I think in the last week or two, a 50 megawatt project energized in Northern Ireland. So there's a huge challenge there, not just in building the renewables, but also getting the system ready, but huge opportunities, and it also then transitions into other aspects of the energy sectors in terms of electrification, heat and transport, and then emergence of new sectors like hydrogen. So at the moment, I'm involved in a research project along with DCU and Murray Institute looking at implementing hydrogen potentially from a feasibility point of view on projects, some wind farm projects in Ireland. And say it's a new exciting area, but we will need that sort of long-term storage to be able to accommodate all this renewables on our system. So anyways, that's just sort of setting a wee bit of the context. And partly within that there, to go to 70%, I don't think it's a question, do we do it with offshore wind, onshore wind, solar, large scale, small scale? The real answer is we need all of it to be able to achieve these targets. And that very much is where small scale renewables fits into the mix. Like, I suppose historically as a country, we haven't done a lot of small scale renewables to date. If you compare it to Northern Ireland, which would have had a large amount of smaller renewables in their system already, it was partly driven by support schemes. But on the assumption that we are going to start doing more small scale renewables, and linked into that is community renewables. So some of what I'm going to talk about this evening is the new special community renewables, which is actually defined as at the moment as projects up to 5 megawatts. So very much in line with what I'm talking about this evening in terms of, I know it's maybe not correct calling them small scale, but just within the sector, it's easier to break it into micro, small scale, and large scale. Okay, so moving on to talk about the grid connections for the scale of generation. So the couple of questions you really ask when you're looking at grid connections for any project. First of all, well, what scale of a project are we talking about? Is it, are we talking about micro, small scale, large scale? Many megawatts, kilowatts is involved. And the second thing is, well, how's that energy going to be used? Is it going to be used on site to feed, a domestic dwelling? Is it going to be used in a factory? Or is it going to be used for large scale export onto the grid? And by answering those sort of two questions, you sort of can put yourself into a category as to how you're going to be treated when it comes to looking for a grid connection. And that's what I'm mainly focused on this evening, talking about, how do you go about getting a grid connection from ESP Networks and EirGrid for your small scale generator? What's the processes and what do you need to consider? So I've sort of broken it into, the different categories of generation and what processes you have to go through with ESP Networks to get a grid connection agreement with them. And then I'll go into each of those processes in a bit more detail. So the first is microgeneration. So microgeneration at the moment defined, I think it's 6 kilowatt single phase, 11 kilowatt 3-phase. And ESP Networks have their sort of informant fit process. And I'll go on in the next slide and talk a bit more about that. But just to sort of break out the other processes before we go into a bit more detail. The next one is, well, what happens if I just want to use all my energy on site? I don't want to export onto the grid. I just want to use all this energy on site, but I'm more than 11 kilowatts. So I'm not really a domestic type installation. I may be putting a wind turbine or solar panels onto a commercial or industrial premises, but I don't want to export. That's generally referred to as the zero export process. And that's actually fairly straightforward. And that's why a lot of people doing auto production on commercial industrial sites are using this process at the moment. If you do want to export some energy and you're in the range of 11 to 500 kilowatts, or if you're an auto producer, so on-site generation, you can go through your process referred to as the non-batch process. And sort of at this stage, I have to apologize a wee bit. Like our sector within the wider industry, it's definitely full of acronyms and specialized names for processes. And I'll try to introduce you to some of those this evening. But there's the non-batch process, and we'll obviously come on to the batch process in a minute. But there's the non-batch process if you're that size of generator. There's then this new category for community renewables, and that's defined for 500 kilowatts to 5 megawatts. If you're less than 500 kilowatts, you can go through the existing non-batch process. But there's a special category now for community projects, and they again go through the non-batch process. Because everything above 500 kilowatts looking for export capacity that isn't a community project, they go through the batch process. And the batch process is really EirGrid and ESB taking a large number of applications and over a period of time processing those applications together. And when those applications are processed and finished, they move on to the next batch of applications. Previously, the first 3 batches were referred to as gate 1, 2, and 3. Now we've moved into referring to them in another acronym, the Enduring Connection Policy, ECP. So we've had ECP 1 now, which was really gate 4. And now we're having another batch called ECP 2.1, which is literally just starting to be processed. So I'm going to go through each of these in a bit more detail. But that's sort of almost the starting point is which scale and type of generator, and what bucket do you fit into? And maybe this slide would help sort of direct you towards that. So the inform and fit process, so this is more the microgeneration. I'm not going to spend a lot of time on this evening. It's a fairly established process now, and it's usually managed by probably the installer. So I have some rooftop solar on my house, so they would have went through this inform and fit process. And basically, it's not a very bureaucratic process. You're really informing ESB that you're putting a generator on your site. You're confirming that you're using already type approved equipment, particularly the inverters. They've already been approved by ESB networks. And that allows you to go through a fairly straightforward process where you're more informing ESB. If there's any issues, ESB will come back and tell you, but I don't think there's been any to date. And that's mainly because we haven't had a large amount of installations really of microgeneration scale yet compared with Britain or Northern Ireland. But assuming maybe we do get some new microgeneration tariffs coming in, I can really see this sector taking off even more so than what's happening at the moment. At the moment, you don't really get paid for export. There's no real way of getting paid for it. You can put in a meter, but it's quite expensive. But I think all this is going to change because, as mentioned in the bottom of the screen there, as part of the climate action plan that was announced from the government last year, Richard Britton initiative, one of the actions was in the whole area of microgeneration, partly being driven by sort of the new government agenda, but also from Europe, from the clean energy package, that, people have to have the opportunity to generate their own power and to be paid for it if they're going to export onto the grid. So there's new rules and processes coming for microgeneration, and there's some working groups within the government looking about how to implement that. Probably we'll hopefully see something, I'd imagine, in 2021, 2022 in this. And maybe as well with the green influence in the current government, I would expect that there's going to be more of a push in the whole microgeneration area. So, but moving into sort of back into small scale generation. So the other thing I said I'd mention is if you want to do zero export. So for example, there's a wind turbine in, I think it's Dundalk IT. So that would be within an existing factory or commercial or educational premises. And they're really producing power for their own use. Now, if they want a fairly straightforward process, because they already have a connection agreement with ESB networks for connecting their facility, all they're really doing is modifying that agreement to say they're putting in a generator, but they won't export power. They're only going to feed themselves. The ESB networks still have to be informed of this because it's still going to be a generator paralleled onto their network. So there'll still be extra protection equipment that has to be installed. And ESB will want to make sure that, you are, installing your generator, compliant to their network requirements with the appropriate, for example, G10 or Egypt type protection that they require. So that's why you have to, go through the connection process. You fill out what's called their NC5 form, but it's a reasonably straightforward process because you're not looking for any export capacity. That's where things get a bit more complex. So at the moment, most people doing the likes of rooftop installations of solar, they're really going through this process because within a couple of months of applying, you will get a modified agreement to allow you to do this in the majority of cases. And it allows people to get on ahead and get their rooftop installation because at the moment, most of this is probably rooftop solar. There's the odd single wind turbine going in, maybe an industrial premises, but most of it is probably rooftop solar at the moment. And a lot of them are using this process. Because if you actually look for an export agreement, which I'll come on to, that could actually take years to possibly get that agreement. So if you're trying to get your installation in, particularly if it's possibly being grant funded, you have certain deadlines. So you can't really be slowed down waiting to get permission from ESB to install your solar panels. So the zero export process is a fast track way of doing it. Now it does have negatives because what happens at times when you're not using the power on site, you literally have to turn down the generator. With wind, you'd probably spill some of the wind off the blades, or with solar panels, the inverter will basically produce less power. But it could mean that there are instances then when you're actually you're turning off renewable power that could be produced and exported. And that's maybe a deficiency in this process, and why going forward I could see more and more people wanting export capacity. And I think that's where ESB networks, who are the distribution system operator in Ireland, they're really going to have to, step up more to being able to provide more and more export connections. Because at the moment the processes are very bureaucratic, and there's probably going to be changes required there if there's going to, particularly when there's an increased demand for these types of connections. So moving on to the non-batch process, and this is talking about if you want export capacity. So, whether you're a greenfield site where there's no demand, so it'll be fully exported. So it might be a small wind farm with a couple of wind turbines, or a small solar farm. So they'll need export capacity. Or if as part of your installation on a factory or a commercial premises, you want export capacity for the times when you're not using the power, for example, weekends or whatever, well, then you have to go through this non-batch process. And that's for generators between 11 kilowatts and 500 kilowatts. It's also for auto producers. So if you're a factory that has an import capacity of just a megawatt, you can use this process and get an export capacity up to twice your MIC, your import capacity. So you could look for up to 2 megawatts of export capacity through this process. From this year, they've actually started including community projects, and I'll come on to them in a minute as to what is a community project. Just to also note, as I mentioned, there's the working groups around microgeneration, and one of them is looking at the actual threshold for microgeneration. And the CRU, the regulator in Ireland, has flagged that they are looking at potentially changing the actual processes for between 11 kilowatts and 50 kilowatts. I'm not exactly sure what they're going to bring in, but they are saying by the middle of next year, they want to bring forward a simplified process for that scale of generator. So in terms of the non-batch process, so they're generally being, these are applications that are coming in one at a time. So they're not being processed as big batches. Now, there might be the case that, your application, because you've put it in at the same time as a batch and you're in the same general area, you might be processed as part of an ongoing batch. But generally, these are applications processed one at a time in each area. And also key change that came in about 2 years ago is that you need planning permission to apply. You need planning permission for your generator to apply into this process. And this sort of removes the possibility that people will be speculatively securing export capacity on the grid, because they've actually shown that they have a real project, because they went through all the work required to go and get planning permission for it, whether it's whether it's solar generation or wind generation. So that's a key requirement. Now that's maybe where, before somebody goes and gets planning permission, they might want to start trying to understand, is there actually export capacity on their grid? And I'll come on to that later on into some of the areas you need to consider when you're considering how viable is your project from an export perspective. In terms of the number of applications that can be processed per year through this non-batch process, at the moment it's limited to 30 per year, and 15 of those are being set aside for community projects. Now, at the moment, there's not a large amount of developers looking to go through the non-batch process. That's because most rooftop installations are going through the zero export approach, because it's quicker and faster than the non-batch process. But I don't really see that as being sustainable, because if somebody wants export capacity, we need to come up with a better process, because usually this could take up to 9, 12 months or even longer to go through the non-batch process. And for a lot of small scale projects, that's just too long to wait to find out whether you're going to get a grid connection agreement or not. So as I mentioned, I'll talk a bit about community projects. So this has basically been driven by, I suppose, the government's policy to really encourage community ownership of renewable projects, which is clearly a very, very good thing. And to help communities, they've come up with a specialized process for them. So for all other export connections, for the non-batch process and for the batch process that I'll talk about in a minute, you need plan permission. Whereas for community projects, what they're doing is they're allowing them to enter the process earlier before they receive plan permission. But that can allow them to, at an early stage, engage with ESP networks to determine if the grid connection is viable before the community takes the project too far down the road in terms of investing in things like plan permission. There is a fee for this, and it's the lowest fee that ESB generally charge. So there's an initial application fee of $2,000 for a community project. So they pay that fee, and then ESB will study their application and give them an indicative connection method and cost. The generator then has 2 years to take that information, go off and get plan permission for their installation. And then if they come back within the 2 years, whatever connection method and cost ESB had indicated to them, ESB will give you a connection agreement on that basis. If you come back after the 2-year basis, they'll reprocess you and still give you an agreement, but they mightn't be able to give you, the exact same connection method and cost because other people have maybe taken the capacity, but they're still holding that capacity for a period of time. And in a way, for projects of this scale, it's probably a reasonably priced, detailed feasibility study for communities that can be turned into a connection agreement. So I think it's quite a good innovation between the regulator, ESP networks, and I think the department and SAI were certainly involved in the discussions in this new process as well. The other thing that the communities can do is, as soon as they put in their applications, they can start engaging with the ESP networks. And that could allow, before ESP networks even go off and do a lot of detailed work, they can maybe even give them an early indication if there's viable and available capacity in their area. Because unfortunately, having connected so much renewables already on our system, there are some parts of the system that are almost saturated with generation, and any new generation will drive quite expensive grid connections. So this early engagement process is maybe an opportunity for ESP networks to explain to the community group, the likelihood of getting a viable grid connection. In terms of the actual community projects, the actual size of them has been determined at 500 kilowatts to 5 megawatts. So that could probably allow for 1 or 2 wind turbines, not dissimilar to the Temple-Derry community project in Tipperary, which I suppose is often the example shown up to show how community projects can work. It has to be 51% owned by an actual proper registered community. So that potentially does allow developer involvement, which does have the benefit of maybe a developer with the experience, the expertise, and the resources to help out. But I do know some communities very much want to do it on their own as well. And at the same time, the applications that they have to put in, they still have to put in these NC5 forms. And they do have to have identified, a location for the generator, a type of generator, and they have to show proof that it is a proper community group. And I think a lot of that's through the fact that the community is registered with the SAI as a community group. So that means, it's not that a community can come along to ESB and go, we've put in an application, now tell us what to do. The community has to come with a proper proposal to ESB. But to be fair, ESB will then very seriously consider that application and really help the community at that stage, hopefully. In terms of the batch process, so now we're sort of moving into large-scale generation. So it's for everything from 500 kilowatts up to hundreds of megawatts. And these batches there was a batch last year called ECP1, and there was an application window for the next batch, ECP 2.1, the September just gone past. So people are just getting invoices now for their projects. So they've just been issued. So there's going to be one of these batches every year. There'll be a batch this September, next September, and the following September. And each of these batches are going to process 85 applications. Now, at the moment, there's about, as you can see in the graph in the bottom, there's actually about 150 projects queued up, wind, solar, battery projects wanting grid offers. So, so over the next 2 to 3 years, hopefully they will address that backlog. But at the same time, the renewable industry is quite busy. So there's new projects coming along getting plan permission. Because key to the ECP batch process is you need plan permission to apply into it. So that removes the possibility for speculative applications securing grid capacity. And they've decided that of the 85, 25 will be awarded to the 25 largest projects in terms of renewable energy output, and the other 60 will be based on planned permission dates. So that was viewed as a way of balancing, making sure we have enough large-scale renewable projects going through the system to make sure the RES auctions, which is the support scheme, are kept competitive, but also that people who've been waiting in the queue quite a period of time will get processed. So that's the ECP2 batch process. So that's really for generators looking for export capacity for more than 500 kilowatts that aren't community projects. Just a bit about application fees. So whenever you submit an application, you initially put in €2,000, but then the full fee, which is to process your connection offer. So for example, for less than 500 kilowatts, just say it might be about €1,600 to process an offer. Whereas if you're just say 5 megawatts, the application fee is 37,000. So there's obviously a scale of different application fees depending on the size of your project. And that's obviously just one step in the developing of a renewable project. You'll have obviously probably already spent quite a lot of money getting planning permission, in securing land, in getting whatever professional support you're required to develop the project. I appreciate these fees are probably material, but in the scale of developing a renewable project, they're sort of in line with other jurisdictions. So just a wee bit about, well, is there actual grid capacity for my specific project? I've told you quite a bit about the processes, but will it actually be viable? As already mentioned, at the moment we've about 4,800 or 900 megawatts of connected renewables, and we've another 2,000 or 3,000 megawatts of contracted renewables. So that means there are large parts of the country that are almost saturated already with renewables. And the only way of connecting more renewables will drive a lot of reinforcements to the system. Some of the reinforcements you'll pay for, and some maybe will impact you until they're complete in terms of connection timelines or having your output reduced because of constraints. But whenever you're looking at the viability of your project, like the sort of the questions you ask and you're sort of paring back the onion to see what's behind each of the layers. The first thing is, what size of an onion are you peeling back? So what MEC are you requiring for your generator? What's the scale of your generator? So that's sort of similar to one of the first questions earlier in the presentation. What size generator are you? And then the next question is, well, where are you on the grid, and what grid is in your proximity? Like I would regularly maybe get people ringing me up asking if there's, is their project viable? Like the first thing I do is put a pin in Google Earth with our network database just to see is there any grid in the proximity to the site, because that could be quite key. Again, depending on the scale of the project, sometimes a large scale project can afford to build quite a lot of grid connection back to the existing grid. Like we've been involved in projects connecting 20 or 30 kilometers back to grid connection points. But for the likes of solar installations, they really couldn't afford that level of infrastructure. So proximity to grid is important. What existing grid is there? What existing generation is already on the grid? So this map I have here is actually Ballybunion in North Kerry. And like one of the challenges here is there's already about 10 megawatts of wind contracted into the 38 kV substation in Ballybunion. So, that'd be quite key to then looking at the infrastructure in your area, because, if you're connecting a smaller scale generator, you might look, for example, this WEX here, you might see, is there an MV network near you if you're only looking for 500 kilowatts? But if you're looking for if you're doing a bigger generator, maybe 5 megawatts, it's really, is there infrastructure in the local 38 kV substation, for example, Ballybunion substation? So at the moment, the Ballybunion substation, the transformers are probably saturated with the existing generation that's there. So any more generation will drive transformers. You also need to look at the 38 kV network that feeds those transformers, and it may be overloaded and it may need uprating, because as well as the Ballybunion substation, there's 2 more substations to the south of Ballybunion before you get to Tralee 110 kV substation. and there's 1 or 2 before you get over to Treen substation and the Stole. So the 38 kV network, particularly in Ireland, can be quite long. So if you put too much generation into it, you'll overload it and it might need upgrading. Then there's the transformers back in the 110 kV substations. So in this case, Ballybunion's normally fed from Treen. And there's quite a bit of generation already in Treen. Maybe it could accommodate some more megawatts, but it wouldn't be able to accommodate maybe another 20 megawatt generator without requiring upgrades. And it's not unusual to have to pay for upgrades. It really is a viability question. Can the generator of your size afford to pay for that level of upgrades? And that's sometimes when during the feasibility stage you have to come to the conclusion the project isn't viable because there isn't the capacity in your area without expensive upgrades. And then there's the wider 110 kV system. There's certain parts of the 110 kV system, like North Mayo and up in Buncrana and then the Shoan Peninsula, that's basically already saturated. And I think it's getting to the point where you just won't be able to connect more generation until EirGrid put more 110 kV infrastructure into those areas. And it's the cost of all these upgrades you sort of have to look at. So this is what we usually do in a feasibility study, is we're literally going through these different layers to understand, is the project viable? There is information out there that is made available from ESP and EirGrid to help people do this. So for example, ESP earlier this year have brought out their generation, I suppose they refer to them as sort of as heat maps, but what they really are is they're doing transformer calculations in 38 and 110 kV substations. And they're telling you if there's capacity left on the existing transformers for generation for export. So it's one useful source. They also have information on transformer sizes. Unfortunately, at the moment, we don't have maps of the distribution system available from ESP networks. But as well as considering just the transformers, and hopefully ESB will sort of expand this heat map service, that they'll also look at not just the transformers and substations, they also need to look at the 38 kV capacity and maybe get more information on the location of generation. And as well as the distribution, there's quite a lot of information available from EirGrid on the transmission system. So for example, as I mentioned earlier, there's the Tomorrow Energy Scenarios assessment work where EirGrid have looked at the system in 2030, and they've indicated, based on a build out of renewables to achieve 70%, what parts of the system are going to be very saturated and need reinforcement. They put out constraint reports. So the map on the right is an example where I've taken all of EirGrid's constraint reports. I think there's about 12 of them, and I've actually mapped one of the scenarios. And this is telling us how much they may have to turn down generators in certain areas until reinforcements are complete. So for example, the real area that needs a lot of reinforcement is the northwest of Ireland. To be fair, Munster received quite a lot of reinforcement over the past 10 years to help facilitate renewables, but we've sort of fallen behind, particularly in the northwest. So that's why you're seeing quite high constraints projected into particularly, Donegal, Leitrim, North Mayo and Sligo. But that's actually coming from very useful information put out by EirGrid. So that's sort of examples of where you can get information, to understand the viability of your projects. And obviously you can engage, particularly EirGrid do allow customers to come in and engage with them, but that's more for large scale generators. For small scale generators, unfortunately at the moment, ESP networks don't really have that sort of customer relations role of sort of interacting independent or directly with generators. So that sort of brings me to sort of conclusion on sort of the information I just wanted to put across to yourselves this evening. But I think the plan now is to have some discussion and some questions.
So yeah, thank you, Rory. My name is Michael Donovan. I'm a member of Engineers Ireland. I'm also a member of Engineers Ireland Cork region. So we have a few questions if you're ready to answer them, Rory. So firstly, you probably answered this at the end. Who has access to view the grid map, or how do I find out about the grid in my local area?
The transmission system maps would be on some EirGrid documents like the transmission forecast statement. ESP Networks a number of years ago used to have actually maps on their website, and for various reasons they've taken them down and they haven't brought them back up again. So unfortunately, I suppose people like ourselves have our own database of where all the lines are, but it's the type of thing actually, as an industry, particularly through the representative bodies I'd be involved in, like we are pushing ESP Networks to put more and more information in the public domain, because it's, as things get more and more complex in a way, because we're trying to put more and more generation on a network that isn't really growing in terms of extra lines. We're in a big data world. The more information you have, the more intelligent decisions you can make. So, unfortunately, I can't actually say there's the publicly available way of finding out where the network is in your area.
Okay, that's that answer. Is Ireland lagging behind when it comes to exporting capacity to the grid? How do other EU countries' utilities infrastructures compare on this?
Well, in terms of renewables, I think we're the highest onshore wind across Europe. So I think we're doing very well. We're probably up there with Denmark. I think Denmark is higher because they've already a reasonable amount of offshore wind. Like other countries might be doing better than us in renewables because of their sort of indigenous hydro generation that they would have had for a long time. But in terms of penetration levels of renewables, I think Ireland's doing very well, particularly as we're a small system. So we have some challenges that other countries wouldn't have, like in mainland Europe or in Britain, such as curtailment, where we actually turn down renewables at times because we do too much renewables on our small system. Whereas other, because of the interconnectivity of mainland Europe and just Britain being a bigger system. But these are just additional challenges. I'd say if you're interested in 2021, I'll come back and give you one on curtailment. It's a topic in its own right.
Yeah, just a kind of a follow on from that question just came in. Export limiting scheme is sometimes something that is used in the UK. Any clue how this may be applicable in the Irish context?
Well, for the likes of zero export projects, you're not allowed to export. So you have to put some sort of throttle or zero or limiting scheme. And basically what it is you basically have to put a sensor on your export at the export point to make sure you never export through it. So you put some CTs there, and that feeds back into your power controller that's communicating with your inverter for solar or with your wind turbines. So you basically have to throttle back to ensure you don't export if you have a zero export scheme. So like that mechanism is reasonably proven. Like even diesel generators would have it in industrial premises. So it's not really new technology.
Okay, yeah. Another question. Why do auto producers have a maximum import capacity less than 2 times the maximum import capacity?
So I suppose the logic behind that is like you don't want somebody coming along and putting 2 wind turbines on a Tesco's that only has a small Tesco's at that only has maybe a 200 kilowatt demand. Like what they're doing is they're trying to encourage auto production, self-generation, but they want to put some limits on the scheme. So like anybody who's producing more than twice their import, is really producing power for export. So, this special process for self-generation, they did try to put some sort of limit on it, which is, quite reasonable. Like it does allow you to put quite a big generator generally on your facility.
Okay, yeah. Another one. Does the network allow for renewable energy communities, like a group of houses, buildings with individual grid metering, who can generate and share renewable power amongst themselves and export the excess to the grid?
Well, at the moment, they would all have to do it individually. But I do know there's a couple of projects going on around the country, trying to see, ESB have one down in Dingle. There's some guys doing some stuff in the Aran Islands. There's another association called Mega are doing stuff in Limerick and up in Tala. And that sort of trying to look at how communities can work together at that local level, to sort of buy and sell electricity and stuff like that there. So it is something that's certainly been looked at. It's a wee bit down the road still. And I'd say it's an area, like in terms of renewables, I think as a country, trying to accommodate a large amount on transmission system, the likes of some of the work EirGrid have been doing on DS3 and all. It is world leading, to be fair to them. But I think in terms of maybe down at the distribution level and having smart grid and that sort of community renewables, where we probably are lagging behind, other countries in Europe. And it's not that, okay, we're lagging behind, but we can actually go and learn a lot from other countries about what they've done and maybe implement it a wee bit better from their lessons.
Okay, thanks for that. There's a lot more questions coming in. So I might just take a few more if we have a bit of time. So let's have a look. What penalties will Ireland be paying for their not meeting the EU renewable energy targets for 2020? Does that have a...
Well, first of all, our actual target isn't 40% renewable electricity. It's actually 16% renewable energy. And off that, there's a target within heat, electricity and transport. I think the heat and transport sector is around 10 and 12%. And the electricity was 40%. But the electricity is the one closest to meeting its target. So I think overall, we're somewhere around 12 or 13% towards meeting the 16% renewables. So we have missed it by a number of percentage points. And I suppose different people have estimated what that penalty may be, potentially in the hundreds of millions.
Okay.
So there is going to be a potential consequence to it. So, but I think we've been good in the renewable electricity, but being a wee bit honest too, we could have hit that 40% target. Northern Ireland has actually hit their 40% target. If we had been a wee bit better about how we issue grid capacity, how we, move support schemes on, we would have hit our 40% target. The renewable projects were out there to be built. So there's some lessons there for, the next targets.
Okay, I might just take a couple of more questions. So under the informant fit process, do ESP networks store technical data relating to microgeneration units? This would be key to the future demand forecasting.
Well, I think that's one of the purposes of why they actually want people to apply, is so as they can log all that information against MPRN numbers, so as they actually have that information. Because maybe in the future, which was the case in Northern Ireland, where there's a large amount of rooftop installations, they had to limit the amount of installations per street, because there is the potential in the future that you could be overloading the network with export. But maybe in the future, what will be, the bigger challenge maybe for ESP networks isn't going to be microgeneration. It's going to be the increased demand because of everybody having electric cars and possibly electric heating through heat pumps and stuff. So actually, the microgeneration at that stage might be part of the solution that networks will require more than the problem.
Okay. During the planning and implementation stage, what lessons did you learn to fast track projects?
Well, I think first of all, I do see projects coming across my desk which have very, very challenging grid connections, possibly unviable ones, very late in the processes. So I do think it's well worth at an early stage, particularly as the system's very saturated, to do some early feasibility work, because particularly for things like communities, like building a renewable generator is one of the options for your community. There's loads of other really good renewable energy projects you can do, and it's horses for courses. Some communities might be able to do a large scale wind turbine project or a solar installation project, but just because of the nature of the grid in your area, it might be viable. Find that out in an early stage and go off and put all your good energy and resources into things that can be done, which might be renewable electricity. So I do think it's about getting it understood at an early stage. And I do think actually, and this is why I think these events are brilliant, because I think, there's more education required around, giving people a better understanding of things like electricity grids, because there's a wee bit of complexity in there, but the more you read up on it, it's not rocket science at the same time.
Yeah, I might just take two more questions. So how feasible would it be to convert non-exporter to exporter in the future? Is the current policy going to have long-term effect?
Well, it's actually what people are probably doing is the easiest way of getting like an on-site generator connected is go zero export. But then once you've got it zero export, the next thing is, well, there are times maybe you're not using the power, so then you probably should go to try to get an export agreement. Now, there might be export capacity. So before you actually build your project, you need to make sure you're not dependent on that export capacity. But if you're not dependent on it, it probably does make sense to do it in 2 steps. Get it built under zero export and then apply for export capacity. Like, the one thing I would say is, like, there's great opportunities for us to have a smarter distribution system. Like, at the moment, it's just historically been, designed as a fairly passive distribution system. So we currently have a distribution system that's designed to work in the extremes. So it'll work in the extreme of maximum demand, no generation, or minimum demand and maximum generation. So at the moment, we actually plan our distribution system for a windy, sunny nighttime when demand is lowest. So there's huge opportunities to come up with a smarter distribution system. And I think that's the real challenge for ESP networks in the next 10 years. Like, EirGrid really stepped up to that mark in the previous decade. I think the big challenge for networks is to step up now and to bring us a smart distribution system. And that should mean, there's more capacity on the system and it's more of a live system. So particularly for installations where, they've been built without relying on export, but if they can maximize the export, it'll maximize the project, and get more renewable energy in the system. But you might be able to export all the time, but that may be okay. And to do that, we need a smart distribution system.
We might just finish with this. How would a battery, flywheel, and hydrogen storage work with grid constraints?
Well, there's different types of things drive constraints, and some of the solutions for it. Need to first of all, you have to understand the type of constraint problem you have, and then you can see whether your technology is a solution. So, for example, a lot of the day-to-day challenges I see, is as showed that constraint results from EirGrid of the map of Ireland. You can see all those red and orange dots up in Donegal and Mayo. That's basically all that wind up in Mayo and Donegal trying to export out of lines to Dublin. Because at the moment, Connacht and Donegal is a net exporter of renewables. They're hugely successful, but almost too successful. But the problem up there is at times of high wind, we can't export it. Now, if you put in a battery that maybe has a life of an hour, the problem with that there is, like, the wind will fill the battery up after an hour, and it's still going to be it still could be being constrained for another 2 days. We've done constraint analysis in 2030 where you could have 4 days steady constraint. So the idea of storing electricity to put it back in electricity, I actually don't think is great on a high wind system. What we really need to do is store electricity and put it into heat and transport, because that's the long-term challenge. We have to use renewable electricity, yes, to decarbonize the electricity sector, but also as the main generation source to decarbonize heat and transport. So how do we turn that into? So I don't think it's a battery. I think maybe a battery in a car, because that isn't going back into electricity; it's going into transport. So I do think those coupling of the heat, transport, and electricity sectors, that's the holy grail we'll be aiming for to decarbonize our whole system. And that's the areas I see sort of storage suiting in Ireland. On a high solar system, the sun goes down every night and the battery will export the grand. We don't have a high solar system, we have a high wind system. But going back to one of my earlier slides, there's huge opportunities in all those areas. Like, we're going to need, somebody mentioned flywheels or synchronous condensers, all those new technologies. We're going to need all those types of things to run a really high renewable, low carbon system. So, and we will be building more batteries. So there's a place for batteries, but they're not actually really storage devices. They're more actually providing system services like inertia and ramping capability and stuff like that there. So I do go back to an earlier point. We will need some of all of that. Nothing is a bad technology, but some things will suit Ireland more.